Hello, welcome to my talk, Build Plugins with Pluggy. Who am I? I'm R.Kracekumar from Bangalore. I'm a software engineer. Apart from writing code, I like reading fiction and reading poetry. How is the talk structured? The talk is structured into three sections. In the first section, I'll give you an example code and I'll give a reason like why that particular code needs to be written as a plugin. In the second section, I will describe what is a plugin and introduction about Pluggy. In third section, we'll discuss about how Pluggy works and what are internals of Pluggy. Why develop as plugins? During the course of the talk, for all the code samples, I will use a simple command line application which gets user input from the user, and the program queries the user input data to the Gutenberg project and returns the result and formats the result and prints it to the terminal. So in the first section, I'll use the same logic to explain the shortcomings of the that particular approach without plugins. And the final section, I will describe how this exact same code can be written using plugins and what are its advantages and how we can easily extend that particular piece of code. As you can see in the screen, the application has got a method called run which orchestrates the functionality of the application. First, it calls the method self.getInput. Get input gets input from the user, sanitizes the input, and then next the processor.process function processes the data. Third, search method searches the data from the Gutenberg project and returns the result. And finally, render output is called with output and the format. The render output implements formatting for two formats. One is JSON, other is table. So what are the shortcomings of this function render output? The first shortcoming is it is hard to support all the available formats. As the number of format increases, it becomes hard to keep up with the format and it needs a new release for every new format. Second, it is difficult to extend support for all user requests for this particular output format. Reason being, there are users who use different operating system. There are users who use different formats which are used in very specific purposes. So it may not be feasible and may not be practical for the library maintainer to know all formats and have time to implement all of them. Third, it is not extensible code. As a result, it is always relied upon the developer of the project to keep adding new feature. Next, plugin system. So what is a plugin? So plugin is a software component that adds a specific feature to an existing computer program, and the plugin modifies the behavior of the program at the runtime. For an example, most of the major browsers support the concept of an extension or an add-on. That's an example for a plugin. And the operating system Linux supports all drivers as a plugin, and which can be added at runtime, can be disabled later. This is a very good example for plugin. So what is Pluggy? So Pluggy is a Python library which provides a structured way to manage, discover plugins and enable hosts to change the behavior of the host program at runtime. How Pluggy works. Here is an output of a tree command for a sample plugin. As you can see, the repository contains various files. The important files here are three. The first is host.py and second is hookspec.py, other is output.py. We will see what these files does in next coming section, but remember these three files are very important. So before getting into how Pluggy works, we need to understand some basic terminologies. The first terminology is host program. In our example, host.py acts as a host program, and the main objective of the host.py file is to take care of the life cycle of this application. In this case, a host.py is responsible for getting input from the user and querying the Gutenberg project and calling the appropriate hooks and returning the response. And next terminology is a plugin. The plugin is an implementation detail of a particular behavior. In this case, output.py contains the behavior details. Print output is the function which implements how the search results needs to be rendered to the screen. Next is plugin manager. So plugin manager is very important and the core of Pluggy functioning. Plugin manager's work is to bring together the hook specification and the implementation and enable the hook calling. Hook specification. Hook specification lies in hookspec.py file. Hook specification is a blueprint of the plugin, which defines what is the hook name, what is the function signature of the hook. Next is hook implementation. The hook implementation is the implementation detail of the hook specification. The hook specification does not contain any body in the function or a method, whereas hook implementation implements the actual logic or the behavior of the hook specification. So here is the higher level overview of the host.py, and all the actual code has been replaced with the comments for brevity reason. Let's see like what exactly host.py is doing with some kind of an understanding of the functionality. The first is like setup.py function. Setup.py function calls a get plugin manager. The get plugin manager function has got one responsibility. It first creates a plugin manager object, and then it adds plugin specification and adds plugin implementation, and then it calls the hook get click group. For example, since print output method may want to have some extra details, extra user options which are not passed down in the default search functionalities, so those are created by the plugins. This is where extensibility feature becomes important. And the next is CLI. So for managing the user input, we are using a click dependency. Click is a Python library to build command line application. And then the control comes to the search function. Search function validates the user input and manages the search flow. That means it calls the search instance by passing the user input and hook and other configuration details. Okay, and then the flow goes to the run method. So run method makes a request and then it goes about calling the registered hook to print the output. This is the very high level overview of the host file. We'll come to see like how each and every section of this is implemented. Pluggy has 4 high level concepts or 4 high level steps, and the first step is defining the hook specification. The hook specification is declared in the hookspec.py file. First step in hooks specification is creating a hookspec marker object with the project name, and second is declaring the function or a hook, and then decorating the function or a hook with the hookspec marker. Now we have to consider hookspec. What is hookspec? Hookspec is a blueprint for the plugin. So hookspec has an empty body, but it has got a function name which will be taken as a hook name, and it has a function signature which will be used by the hook implementation. The second step is actually writing the hook implementation. In this case, the hook implementation lies in output.py file. The first step to create a hook implementation is to create a hook implement marker object with the project name same as hook specification, and then we create a function with the same name for which we want to implement the hook implementation, and then you decorate the function with the hook implement decorator, and the actual logic goes into the body of the function. Now let's look into what actually the implementation details are. First, what we do is like we get the response JSON and we got the data. Next is figuring out what data need to be printed. In this case, we convert the JSON data into list of dictionaries with 7 keys in each dictionary. And the first is the author name, and second key is a bookshelf details, third key is copyright information, fourth details is download count, fifth one is the title of the book, and sixth one is the media type, seventh one is XML information. Now that we have the details to print on the screen, now let's go about figuring out the formatting and other details. Now we get the indent information from the config which was passed to this particular implementation. Then if the format is JSON, that is like this print output implementation will only print the data in JSON format. If user has passed on the some other format like a YAML or XML, this print output will not produce any output. And then we format the dictionary into nice JSON format. And if the user has asked us to colorize, we call the colorize function. For the brevity reason, I have not included the colorize logic, but it is available in the source code, which I will share at the end of the talk. And if there is no colorize option, we print it like a normal formatted JSON with the given indent details. Now, this is the important part. Now is the plugin manager. Now that we have seen how to do a plugin, how to do a hook specification and the implementation, now let's try to see how we can bring these two pieces together. The role of a plugin manager is to bring together the various components involved in building a plugin. And the first step is creating a plugin manager with the same project name as that of a hook implementation and Hookspec. And second is adding a hook specification using the method add Hookspec, and add Hookspec can be spread across multiple files or multiple modules. And third step is registering the plugin using the method register. As you can see, both hook specs and output objects are nothing but are Python files which are imported. It is possible that these plugins are distributed in Python package index. In that scenario, we cannot use pm.register method. We should use this method called load setup tools entry point with the same project name. So this will look into the Python path and load all the entry points which are registered using the same project name. Now that we have set up all the details for plugin manager, now let's go to the final step, how this all comes into play. And the final and important portion is like, how do we invoke the hook? Here is the search function and the search class. The user input is received using this click library. The search function takes 3 arguments. One is title, author, other one is like keyword arguments. If you are wondering like why we have used ** KWRs here, because the plugin may have registered certain options, and those options may not be available, or name of those options may not be available while writing the host.py file. In order to receive those configuration data and pass on it to the plugin, we are using ** KWRs. Here the search function checks for some conditions. If both title or author is missing, the program ends. If not, we create a plugin manager and then we create a search instance and we run the search. And let's get into the search class and see what it does. Search class has got three attributes. The first is the term, and second is hook, third is the configuration details. And run method calls make request, which makes a request to the Gutenberg projects, and we have the response after that, and then it calls the hook print output with the response and the configuration details. Now that we have seen a plugin example, let's try to see the output of the plugin example by running a few user supplied inputs. Here are two outputs for the same program host.py with same argument my freedom and bonding, but with a different configuration of indent 2 and 4. In first case, we can see in both the cases we can see the output data is same, but the formatting is different. In the first case, the plugin is formatting the output with two spaces, that is JSON indent S2, and second case it is outputting the data with indent S4. Here is a visual representation of how plugin works. The gray box represents the host program. All the other blocks inside the gray blocks represent the logical functionality of a specific pieces. The program starts when the user types in the program name and enters the user input, and then what happens is the plugin manager gets called, and when the plugin manager gets called, the plugin manager does certain kind of setup. The first thing is to add the specification. Second is to load all the plugins. In this case, a plugin manager loads two specific plugins. One is output and header. Even though we have not seen the header plugin here, we are using it for the sake of explanation. And once the plugin manager loads all the plugins, now the search functionality kicks in, and after search is over, the hook output is called by search.run, and the hook output receives the data, transforms the data, and returns the data. Once that hook calling is over, then the cleanup blocks kicks in, and cleanup block cleans up the resources and the program exits. In our case, there is no cleanup functionality, but this is an example use case how a plugin will work. Let's speak about Pluggy internals. So what happens when the search.run method calls hook.print output? If you have seen the blueprint, that is a hook specification, and the actual implementation, hook implementation, both the methods print output had same name, one. Second, they had both same signature. So a plugin manager was able to understand this is the hook specification, this is the hook implementation. So there is a table where Pluggy looks up for the hook specification, and it calls the relevant hook implementation. It is quite possible that there may be multiple print output. For example, in our case, we have only implemented JSON formatting. Let's say there's one more print output plugin which implements XML formatting. There's one more which implements the YAML formatting. So now what happens is, like, there is one specification and there are three implementation. In that scenario, what happens is Pluggy maintains one hook name called printout and three implementation details. When the host program calls print output, the Pluggy calls these three plugins in first out order, and all the output from the plugin or the hook is captured and returned to the host program. And then it's up to the host program to figure out what result to use. Okay. Second, now this case can go into a scenario where there are more than three plugins. That, let's say there are 25 registered plugins for a single specification. In that scenario, it is not feasible or it is not performant for the host program to call all of the plugin, even though Pluggy internally manages the hook calling. So to short circuit that, there is an option called first result is equal to true. When the user specifies the plugins or hook specification, So when user specifies a hook specification, here he can pass an argument called first result is equal to true. Once that is passed, the pluggy understands that it should stop calling all the registered plugins as soon as a non-null result is received from the hook. As a result, this will help the pluggy to exit the execution loop as early as possible. And it is also the responsibility of the plugin developers to make sure all the plugins does not raise an exception. If one of the plugin raises an exception, the rest of the plugins which are registered for the specification will not be called and the program will crash. Testing the plugin. So how do we test this function print output? So the print output hook implementation here is a normal Python function. The testing this implementation does not require any special setup. You can call the print output like any other function and assert the result. Here what I have done is like created a test called test print output. Make a request to the same Gutenberg project, and we get a response, and I pass the response to the print output and with an empty configuration. So and then I capture the output from the terminal using Pytest fixture. Once I have the output and I parse that JSON data and check whether the Gutenberg project has returned more than one response or not. So this is how you test a plugin function like any other normal function. So how do you do integration testing? So to do integration testing, we have to have the entire functionality of the application. In this case, the functionality lies in host.py file. So first we set up the plugin manager to discover this Hookspec and hook implementation. Once we have done that, then we call the CLI runner. Since Click provides a nice way to test the command line application, I'm using CLI runner instance from the Click library. Then I invoke the search function with the arguments. That is like term as my freedom and my bondage, and with the indent as 8 and colorize as false. If you remember from the hook implementation, there was a function for colorizing. Since testing the colorized function is very hard, I'm making it argument as a false, and we will only test the output data, not the color. And I will declare the expected output, and I assert the result and assert the output result and the expected result. As you can see, like testing the integration testing for this application same as testing the any other Click application. So testing the plugin is very simple and also straightforward. Here are some examples of a real world project which are using Pluggy. First one is Pytest. Pytest is a Python test runner. Pluggy was first developed to create plugins for Pytest project, and as of now Pytest has got more than 500 plus plugins registered. After that, once Pluggy became popular, other projects started using Pluggy as a plugin architecture or plugin library for the functionalities. And second library is Tox. Tox is a Python library which helps in automating and standardizing the testing. For an example, if you are a library developer where you need to test your library against multiple Python versions, say from 2.8, say 3.5 to 3.9, it is very hard to mix and match the combo. So Tox helps in that particular space to automate and standardize Python testing. And the final project is Datacity. Datacity is a tool for exploring and publishing data. For example, if you have got a data set, you want to published to the public and you want the users to search based on some keywords, you can use Dataset library. Dataset has got nice set of plugins like authentication and YAML output and other kind of formatting. See, all the code whichever I was shown in this talk is available in my GitHub repo. You can go to my GitHub repo, github.com/R.Kracekumar/pluggy/talk. And if you have any doubts or any feedback for this talk, you can reach out to me in Twitter. My Twitter handle is CraceTheKing. Finally, stay safe, wear mask. Thank you.